In this video, we'll go through some past paper examples, and then you'll see they don't really specify, do you need to do elimination or substitution. We can actually do both. It's going to be a bit of a longer video, but just explaining that both would work. I'm not really sure where you're watching this. If you're watching this on YouTube, I'll put a link in the description to my website at the bottom where you can download this and find it there. If you're watching this on my website, just scroll down to the bottom of the page, you'll find this paper. Anyway, enough about that. Let's just take a look. I'm not going to do all of them, but let's just take a look at this one. You can see they just say solve simultaneous equations. You must show you're working out, and there's two of them. So I'm going to rewrite it. 4x minus 3y is 26, and then 5x plus 6y is 13. Oh, wow, I don't know what that was, but it's not a 3. There we go. Okay, so they didn't tell you substitution or elimination. When I look at this, I'd see this 3 and this 6. I'd see the negative and the positive, and I'm thinking the easiest route for me would just being elimination. Because I can double this whole equation, and then those 6y's are going to cancel out really easily. I can see from the marks here, it's 3 marks. So that sounds decent. Should not be too tricky. So I'm going to multiply everything there by 2, and then I'll have an 8x. So I'm kind of doing this times 2, everything. And that negative 6y is what I was looking for. And then this 26 would be 52. Looking at this, such a nice example. 13 goes into 52 nicely. So this should be a walk in the park. Okay, we're going to use this one and this one as our equations. I'm going to add, so 5 and 8 is 13. Wow, 13x. This is going to be plus 0. Don't even have to write it. And then 13 plus 52. Oh my goodness, that is going to be 65. And then x, I'm just going to say x divided by, x, just divide both sides by 13. And this would be 5. So x is 5. And now I can sub it anywhere. Let's just do the top one. So I'm going to say 4 times 5 minus 3y is 26. And that's 20 minus 3y is 26. And then negative 3y is going to be subbing, that's going to be taking the 6 and dividing by negative 3 on both sides, so y should be negative 2. Okay, I didn't check the memo now, but I'm sure this is going to be fine. If it's not, write it in the comments, but this is pretty much what we're going to do. So I'm going to write our answers here. X is equal to 5, and then y is equal to negative 2, and show you that if you decided to do substitution, why did I wipe the question away? Oh man, sorry about that. Just gonna rewrite this again. 4x minus 3y is 26, and then 5x plus 6y is going to be 13. Okay, so if I wanted to do substitution, I can already see I'm going to run into fractions, because I'm going to either have to divide by 4 and then 3 over 4. That's not going to work out very nicely, or divide by 5 or by 3 or by 6. So I'm just going to jump into the deep end, and I'm going to make x the subject here. So I'm going to rewrite this as x the subject, just do a little bit of rearranging. Remember, when we substitute, we have to write one of the variables in terms of the other. So 4x would become 26 plus 3y, and then x would be 26 plus 3y all over 4. And you can see this is not pretty at all, but it should work. It should work. Okay, so this x, I'm just going to sub into my other one. Remember, I can't sub it in here because it's the same equation. You'll just get 0, 0 or something like that. So we're going to try and attempt doing 5, because we're writing the 5, and we're writing this very big, humongous thing, 26 plus 3y over 4 plus 6y is 13. Okay, so we substituted x in there. And now we see we have an equation with only one variable. This should be solvable. what would be easier here? I'm thinking if I were to I obviously want to multiply by 4 eventually. Let's just multiply this in. 5 times 20. Oh my goodness. I'm sure 5 times 26 is 130, but I'm going to use my calculator just to save myself from redoing the video. 5 times 3 is 15. Y, this is all over 4. Plus 6y is 13. So I kind of just multiplied the 5 in. I'm going to multiply everything by 4 now to kind of remove my fraction here. And this has to be multiplied by 4, so that should be 24y. And 13 times 4 is 52, but I'm just double checking myself. Cool. And now I have 15 plus 24, so 15 plus 24, that would be 39y. And here I'm going to have 52, but I'm going to take away 130, so that would be negative 78. And y is negative 2 then, which is the same as what we got there. I can sub this into any of the equations and I'm going to get 5x. That was not the point. The point was showing that if I found the y value, I could find it either by elimination or substitution. But you can see here, you'd probably not want to go this route because there's some big fractions in here and there's a lot of options for mistakes. So yeah, you kind of have to watch what's being given and what will work. But either way will work. They're not going to give you more marks for the one or for the other, and they didn't specify which method we should use. Okay, so that was the one question. Let's see which other one we can find on that paper. Some past paper examples. Sorry, that document has some rearranging formula bits in there as well. Let's take a look at this one, number 7. I'm going to quickly rewrite this. This should be straightforward. This is 2 marks actually, so oh, you can't see it, it's off screen. But anyway, x minus 3y is 7, and then 2x minus 3y is 11. Okay, this is only 2 marks, and you can see why, because these two are 3y and 3y. So the only thing you need to do here is you have to change the signs, and then elimination would be a lot easier. Again, you can do substitution. X is already alone, so substitution will also, let's do both. We're here to learn, right? So let's do both. I would probably go this route and say, well, this is negative 2x plus 3y, negative 11, just kind of changing all the signs straight through. And I'm working with these 2 equations, and I have x minus 2x, so I have minus x, minus 3 plus 3 is 0, and then I have 7 minus 11, so that would be negative 4 if I'm not mistaken. X is 4, and you can see that was super quick. We can sub in our 4 in there, so 4 minus 3y is 7. So I'm going to have 4 minus 7 is 3y, and y is just 1, right? 4 minus 7, no, it's negative 1. Okay, 4 minus 7 is negative 3, and then 3y divided by 3. Okay, so that was really quick. If you wanted to go substitution route, you'd rearrange that formula and you'll make x the subject, which is also quite easy. It's just 7 plus 3y, and then you would sub the x in there. So you'll do this color code. Let's do 2 times my blue equation, 7 plus 3y. Okay, and then minus 3y is 11. And this is going to be 14 plus 6y minus 3y is 11. So I'll have 3y is negative 13. No, wait, did I make a mistake here? That's an 11. Almost thought, what on earth is going on? So this is going to be a minus 3, and then y is still minus 1. Phew! Almost thought I made a mistake there. Okay, mistakes are fine, means you're learning, right? But anyway, not on the video because then I have to re-record. Okay, anyway, so you can see here elimination was quick and substitution is just as quick. Again, I'm not done here. I would have had to sub this in there, but then that's just substitution, and the point I'm trying to make is elimination and substitution would get you to the same answer. And as you can see on our example here, they said solve the simultaneous equations, and they just said x and y, and it was 2 marks. And there was no real, oh, by elimination or by this or by that. I'd probably not do this graphically on here, that would be way too much. So definitely either substitution or elimination. Okay, I think let's do one more. Let's do one more. While I'm rubbing off the paper that you have, I think I already mentioned this, there are some rearranging formula bits in there, and there are also some very advanced simultaneous equations where you get quadratic kind of equations in there. So don't worry about them. You shouldn't be able to do them yet. I still have to make a video for that, or by the time you watch this, I might have already made a video about it, but then it'll say Simultaneous Equations like hardcore mode or something, because that's going to be very tricky. I'll quickly show it to you just so that you know. So this number 12, it's going to be tricky to solve because we have a quadratic in there. And I've not done videos about that really yet. Okay, so let's just take a look at these two examples. We can see here simultaneous equation. Again, nothing is specified as to either of these, whether you should do substitution or elimination. This one is 4 marks and that one is 2 marks. And you can see this one for 2 marks. I'm not even going to do it because you can see, oh, this is just the minus 2w and the plus 2w. They're just going to cancel out. And you're going to have 8t is equal to 24 and t is 2. So this is a really quick one. I'll do this one just because it has equations in it. Fractions in it. So I'm going to quickly rewrite this one, and this would end off our video for today. I'm just going to do it in one way to save us some time. I've already proven that elimination and substitution both kind of work. Oh, no, 46. Okay, just want to double check. Got that right, 4x. Okay, perfect. So if I look at this one, the first thing that I definitely want to do is I want to rewrite this because I don't want fractions in here. It just makes life a little bit more tricky. So I'm going to multiply every single term by 2. And it's important that you multiply this term, and that term by 2, and not just this one and that one. Okay, so this is going to become a 3x, which is fine. This is going to be a 10y, and this is going to be 10. Okay, so now I have these two equations. Let's say, just quickly say I'm looking at these two, but I have a little bit of a problem because this one has a 4x and that's a 3x, and this is a 3y and a 10y. Now I am going to just multiply everything by 10 here, because then I'm going to have I can see here that there's a plus 10y and there's already a negative y in there. So everything here I'm going to have to multiply by 10, and everything here by by 3. And then these signs, they're going to reduce beautifully. If you wanted to do 3 and multiply everything here by 3 and everything there by 4, it'll work out and that'll be no problem. You'll get 12x's on both equations, but then you'll still have to change the signs. Nothing wrong with changing the signs, but you know, it's easier this way. So I'm going to multiply by 10 straight through here. So this one is going to become 40x minus 30, oh, not 3, 30y. 30y, and times 10 here would be 460. And on this one, everything multiplied by 3, so I'll have a 9x plus 30. Why am I making mistakes with this 30 now? 30y, and then times 3, that would be 30, right? Yeah. Okay, so you can see here these two are going to cancel out beautifully. I'm going to add these two, just make a little line for myself. This is my new two new equations, and I would have okay, let's just write it underneath each other. So 49x, that's going to be 0, and that's going to be 390. 490. Okay, and then I just see x is going to be 10, because dividing by 49 on both sides. Oh, so that wasn't too tricky. It's nice round numbers. Sometimes we get fractions here and you might doubt yourself, but if I get a nice number like this, I mean, it's not proof that it's right, but it's just nice. Okay, so I got the x value, so I have to go and check the find out the y value, so I'm going to sub it in there. So 3 times the 10 plus 10y is going to be 10, and then 10y is going to be, this is going to be 30, so it's going to be minus 30 on this side, so that's going to be minus 20, so y is negative 2. Okay, so yeah, I mean, you can see why this is 4 marks, because you, one, had to remove fractions and then multiply both of these equations, and yeah, solve them both. Yeah, let me know if you need some more examples, although I think this was definitely good enough for us. You should have a very good grasp on these. I'll make a video later with the quadratic equations, but I still need to just make a couple of videos on quadratic equations itself. So once I've done that, I'll post the video on this.